Welcome back. We're going to be following up the central angles and arc measures and arc lengths video with some more information about congruent arcs and chords, or chords and arcs. So as always, we're going to start with some foundational information. Two chords are congruent, right? Identical if and only if the following. Their corresponding arcs are congruent, so you might want to press pause and write that down. But then we're going to take a look at AB. So AB and CD are the same if and only if arc AB is the same as arc CD. So that's what we're seeing right here. The two segments, or those chords, are the same. The length of those chords are the same if the arcs are the same as well. Also, we're going to say that two chords are congruent if and only if they are equidistant to the center. So this idea right here, this FE and FG, right? Those are going to be the same distance if AB and CD are congruent. So vice versa. If those chords are congruent, they're equidistant to the center, and if they're equidistant to the center, the two chords are congruent. One cannot exist without the other. That's why we have these, what we refer to are biconditional arrows, right? Biconditional, right? That means two-way, right? This statement can be read from left to right or right to left. Same as the one I'm just about to write. That AB is equal to CD. AB is equal to CD when EF, right? I'll write it in blue, is equal to EG. Okay, so that's what we just talked about right here. Next, if a diameter or radius is perpendicular, right? That means it meets at 90 degrees. If the diameter or radius is perpendicular to a chord, as we see right here, then it bisects the chord, right? There's a lot going on here. It bisects the chord and its arc. So what we're saying is the following. You have this radius here, right? From E to H. Now, if it's perpendicular to AB, which it is, then what we're saying is that it bisected the chord. It also bisected that arc. So this distance right here is the same as this distance right here. And this little piece is the same as this little piece. So we're going to say that with notation down here. If segment EH is perpendicular to segment AB, then, right, the following happens. AF, the length of AF, is going to be equal to the length of FB, right? That's the chord got bisected. And also, the arc got bisected. So the measure, right, the length of arc AH is the same as the length or the measure of arc HB, as noted right here in the picture. So now let's see if we can put all this stuff into action. So there's going to be a lot of stuff going on here. Let's see if we can hold it together. So what do I notice here? I notice that I have a couple of chords and that they are congruent, which means that these arcs are also the same. So if those arcs are the same, algebraically, I can say that 7x plus 24 is equal to 115. And that's just a pretty straightforward piece. Subtract 24 from both sides. And we're going to, 7x is equal to 91. Divide by 7, divide by 7. X is equal to 13. And all they wanted me to do was to find x, so that's pretty straightforward. All right? You complete number 2. Similar, very similar. For numbers 3 and 4, I'm going to set you up, and then you're going to move on your own. So what do I notice? I notice that I have these congruency marks on the arcs, which means that the chords themselves that contain the arc, right? What I mean by contain the arc is WV is the chord, and those are also the endpoints of that arc. YX is the are the endpoints of the chord, also the endpoints of those arcs. If the chords are the same, the arcs are the same, and vice versa. So what do I know about 9x minus 34 and 4x plus 1? 9x minus 34 is the same as, right, equals 4x plus 1. Solve for x. Once I have an answer for x, they want me to find the length of xy. xy is 4 times x plus 1. So I'm going to get a value for that x, so xy is equal to 4 times said x value plus 1. And that's how you finish that one up. I will say there's no decimal answer there. How about number 4? I take a look at number 4, and it's sort of like the reverse conversation. What I notice is that this chord and this chord are congruent, which means that the arcs that contain them are also congruent. So 5x plus 6 is the same as, right, that's what equals means, is the same as 11x minus 72. Solve for x, be your first step. That's not the only thing. They want me to find the measure of arc RS, and the measure of arc RS is equal to 11 times said value of x minus 72. So our final answer is going to be that. After I get x, I'm going to substitute it right here. So you complete 3 and 4 and then move on when you're ready. So now we get a little bit more tricky. Here I notice that I have chord ZY and chord XY are congruent, which makes this arc here and this arc here also the same. So I'll just put a sort of like a double tick mark there. Now, if this ZY arc is 6x minus 20 degrees, then this is also 6x minus 20 degrees because they're congruent, right? So I'll just put that in parentheses with the degree mark on the outside. And then I have that this is 76 degrees here. Now, if I set 6x minus 20 equal to 6x minus 20, this is true, but not solvable. So what I need is a true and solvable statement. Well, what do I know? I know that all the way around is 360 degrees, and I can account for all three pieces to get all the way around. So how about 6x minus 20 twice? Whoops. Right, if I have two 6x minus 20s plus the 76 that was there, that all adds up to 360 degrees. Combine like terms, that's going to give me 12x. Minus 20 will give us minus 40. Plus the 76, I guess, will yield us a plus 36 equals 360. And you could go ahead and finish that one on your own. Hopefully that made sense, the algebra piece. How did we get here is probably the most important. That's the mathematical logic that we're hoping that you pick up in the geometry class. Not just the geometry itself, but the thought process is the most important piece. Okay, so now we're going to shift gears and sort of thought process part B, right? Remember from the original notes that B talked about being equidistant to the center of the circle. So MP and PN, when I look at the picture, MP is here, PN is here. First off, I notice that these arcs are congruent, which means that these chords are congruent, which means that they are equidistant from the center, right? So I should use two tick marks to not confuse the lengths. So MP is equal to PN because they come from congruent chords, so they're equidistant to the center, right? Same distance. Well, since MP equals PN, then 5x minus 34 must equal 2x minus 4. So 5x minus 34 equals 2x minus 4. Now keep in mind that the statement on the left is MP and the statement on the right is PN. When we're done doing the algebra, we'll have an answer for x, but to find MP, MP is going to be equal to 5 times said value of x minus 34. And that'll be our final answer. Why don't you go ahead and wrap that one up. keep in mind, it might be possible to get a negative value for x, but for lengths of things, right, these answers should always be positive. And definitely, probably bigger than 0, right? You can't have a length of 0. So wrap that one up, press pause, and join us back when you're ready. Now 8 takes this idea of being equidistant from the center in reverse. We see that we are equidistant, which means that MN and RP must be congruent chords, which means that the arcs contained by them should also be congruent. So the measure of arc NM should be equal to the measure of arc NP. And the only reason I know that is because if these distances are the same, that was given, then these chords have to be the same. And by that rationale, the arcs contained in those chords should be the same as well. And at the end, I'm going to be able to find the measure of arc MP. Now, let's think about this for a second. MP is over here. So first I'm going to have to find MN, right? I have to find that. Then I'm going to have to find the measure of NP. And I'm going to have to add those two together. And I'm going to have to take that measure of MN plus the measure of NP. When I add them together and subtract that from 360, I should be left with the measure of MP. Let's first double back to our original statement. First of all, 9x minus 43 is equal to 5x plus 33. Now go ahead and trudge through the algebra to get a value of x. When you're done with that, 9 times that value minus 43 is worth the measure of NM. I'm going to add that to 5 times the value of x plus 33. That's going to give me the measure of NP. Now, when I think about those two measures, again, looking at our circle, NM is this part over here, and NP is this part over here. So when I add these two together, I have all of that. Now I know that in terms of degrees, the whole thing is worth 360. So if I subtract what I have here, I'll get what I want, MP. So 360 minus the sum of those two is going to get me my final answer. So go ahead and wrap that one up. Our final thought process was about this idea of a radius intersecting a chord perpendicularly. And what happened? What happened was that it would take that chord and it would split it into congruent pieces. It also would split the arc into congruent pieces. And since these are both radii, then this 90-degree piece here splits this into the same length stuff, right? So these little pieces here, right? My arcs, arc DA, that measure is equal to the measure of arc DB, which is also equal to the measure of arc BE, which is equal to the measure of arc EC. And that's because those chords are congruent, the arcs are congruent, and the radii are splitting them in half. So a lot of pieces are going to fall together really quickly here. Also worth noting that AF is the same as DB, is the same as BG, is the same as GC, right? All these pieces are also the same. Okay, so let's clean that up and see what we got here. First, they told me that BG is 17. So BG right here is 17, which means that this is 17, and that DB is 17, that this is 17. Right? Okay, no problem. Also, the measure of arc CHA is 256 degrees. So from C, ending at A, and going through H, so all the way around here, that, my friends, is worth 256 degrees. So we come over here and we say, well, what's 360 minus 256? That's going to yield us 104 degrees. So what's 104? Starting at C, working to A, is 104 degrees. And how many ways is that split? There's 1, 2, 3, 4 congruent arcs that split that. So if we take 104 and divide that by 4, we get 26. So let's erase this and neaten this up and put in some measurements. So we got 26 everywhere. Now we start answering questions. The length of BC from B all the way to C, that's 2 17s in a row. That's going to be 34 units long, right? And let's just write units, right? Feet, centimeters, so on and so forth. How about from F to B? From F to B, that's just 17 units long, right? 17 units. And then how about arc AB? Arc AB is going to be right here. That's 2 26s or 52 degrees, right? Arcs are measured in degrees. They didn't ask for the length of our arc. They asked for the measure of it. The measure of arc BC is going to be the same as AB, so that's also going to be 52 degrees. And then from E to C is just going to be half of that, which is 26 degrees. Again, label the circle before you go answering the questions, and things get easier and easier. Let's try another one. I guess the question is, how do you know what you're using? Are you using the fact that we're dealing with congruent chords? Are we using the fact that we're dealing with congruent arcs? Are we using the fact that we are, equidistant? Are we using the fact that we have radii that meet the chord perpendicularly? I don't know. I take a look, and the first thing I see here is 90 degrees, 90 degrees, from the center out, from the center out. I think that this one has this concept of radii and chords meeting perpendicularly, and that all kinds of stuff is going to get split in half, right? This gets split in half, and that got split in half, and this got split in half, and this got split in half, and because they are radii from the same center and the same circle, those chords, right, CD and EF are congruent. Also, the arcs here are congruent, right? So just lots of things that I'm kind of holding on to here. Let's see how this plays out. I start looking at the information that was given to me. CI, arc CI is 7x minus 15 degrees. So this piece right here is 7x minus 15. Also, the arc EF is 12x minus 8. So where's that? That's all the way over here. That's the whole thing. So this is 12x minus 8. So I start thinking about how these two are related, and I need 2 of these to make 1 of these. So 2 7x minus 15s would make 1 12x minus 8. Or I suppose I could say 7x minus 15 is equal to half of 12x minus 8. Now, this would work out nice because both of those numbers are even, but I prefer to use the fact of doubling something rather than taking the half of something because I don't want to run the risk of decimals. So let's take this idea. 2 times 7x minus 15 equals 12x minus 8. Don't forget to distribute. That's going to give us 14x minus 30 is equal to 12x minus 8. Now from here, the algebra gets pretty simple. So let's just say that we get some sort of value of x. You can finish that out. What do they want? They want the measure of CI. CI is right here. So I guess when I'm done, the measure of CI, arc CI, is going to be equal to 7 times that value of x minus 15. So this is pretty much a done deal. As we get towards the bottom, again, we have to look. Here's this radius, and it met the chord perpendicularly, which means that we split it in half. Okay, now what do I notice? I also notice that I got a nice right triangle right here. So I'm just going to draw that right triangle right here. This is 5, the hypotenuse is across the street from the right angle. That's 13. So I guess I would say, well, how can I get this? Oh, a squared plus b squared equals c squared. The hypotenuse is 13 squared. So 5 squared plus, I don't know, squared equals 13 squared. And we can get a value for x. And that works out pretty nicely. Once I get the value for x, what I have is this right here, right? That's sort of like my x. Now, if they wanted, oh, I don't know, say they were looking for the length of VW. Don't forget, this piece over here is the same as this piece right here, so I guess it would be two of these. And let's just say I was looking for the arc YW. Okay, how do we get this piece right here? Well, for that, we got to dabble back to some prior knowledge. First piece of prior knowledge is that this is a central angle. So whatever this angle is here, that's the same measure of the arc angle. So I'm just going to draw that right triangle again right here. So here's my 13, there's my right angle, that's my hypotenuse. And this is my 5. And I'm looking for this x angle right there. Right, this angle that's sitting right here between 5 and 13. And so I know that I have the adjacent side and the hypotenuse. So the cosine of x degrees is equal to adjacent over hypotenuse. So x degrees is equal to inverse cosine of 5 over 13. And that's going to give me my angle. Now once I have that angle, whatever that angle is also the angle for arc YW. So the measure of arc YW is going to be equal to the same exact angle measure of the central angle. I know what you're thinking. That's a pretty good magnum leap. You'd be right. But I have faith you can do it. I just want to kind of guide you again in the thought process of where we're going with this. I look at this circle and I think, wow, there's a lot of stuff going on. I see some equidistant stuff here. I see right angles, which means I have radii splitting things in half, right? This is the same as this, and these guys are the same as each other. And I have, this big central angle right here. So whatever this angle is in degrees, this is, I don't know, just kind of brainstorming around. It looks like that we have a right triangle on both sides here. So this is a right triangle and this is a right triangle. And I'm not saying that we really any of this information or all of it. I'm just saying that these are the things that I see. Now, I know that they gave me the fact that HK is equal to 30. So let's go find it. From H to K is equal to 30. And I know that it got cut in half, so that's 15 and 15. And I know that these chords are the same, so this is 15 and this is 15. Handy stuff to know. Okay. I also know that PM is equal to 8. So I go find PM. This is equal to 8, so that's equal to 8. Now these are right triangles, so I know I can get this piece right here. So say they were looking for pH. I could find pH by just thinking about one of these right triangles. So I'm sort of taking this H, M, and P. I'm looking for pH. I don't know that. I know this is 8, and I know that this is 15. I know that this is my hypotenuse, and I know that I could use the Pythagorean theorem to go find that answer. So that's a piece of cake. Then what else? Perhaps we were looking for, I don't know, the measure of GJ. So if I was looking for G all the way to J, this version right here, I have to start thinking wisely. And again, think inverse trig. Now I don't have something that will get me magically to that answer, but I do know that I have this central angle right here. So I know that I could get this arc GH. It's the same as this arc right here. So I'm going to just take that triangle. I'm going to draw it again. This is 8. This is 15. And If I extend out this side, that goes to G, right here. And that comes around over to H. So if I could figure out what that angle is, right, by using some trig stuff. So what do we have here? We have adjacent and we have opposite. So it sounds like tangent of x degrees equals opposite over adjacent. So x degrees is going to be equal to my inverse tangent of 15 over 8. That's going to give me that angle right here. Now if I take that tangent of inverse of 15 over 8, I'm going to gain this arc right here. But that's not what I want. What if I wanted from G all the way to J? Well, this arc here and this arc here are the same, so if I double that answer, that is the arc all the way from G to J. Now, these are bonus level type questions, or maybe open notes quiz type questions, but they're certainly within your reach if you think about it and try to work it through. So don't give up, keep working. So you should consider completing numbers 1 through 16 in this front part of this packet to consider your notes as being complete. If you need help, come up and ask. Good luck.